On Wednesday, we started chapter 15, the first chapter on simulation. You know that in chapter 13 and 14, we talked about and we covered optimization model. In optimization model, our job was to identify three variables. You guys remember that in data analytics, we have three branches. We have descriptive, which we covered in chapter 1 through 3, and we have predictive, chapter 1, 2, 3, and we do not cover predictive in this course, and prescriptive, analytic, which is divided into two branches, optimization and simulation. These are covered chapter 13 and 14 cover optimization and simulation is covered in chapter 15 and 16. So in optimization, our job was to identify three types of variables. Objective variable, some input variables, and condition variables. So in optimization, we have condition variable. These are the variables that are in our control. We can change the values of these variables to come up with the best and optimal value for the objective variable. The second variable is the objective, which has to be maximized or minimized, or we call it optimization, optimized. And we have some constraints that must be met by our model. So we want to maximize or minimize or optimize this variable. These are the conditions that we can play with the values of these variables, and these constraints must be met. In simulation, we have objective variable. We cannot divide our variables into these three categories. Instead, we call them input and output variables. Let me use this word. Okay. In simulation, we have some input variables and output variable. And of course, we have objectives that must be fulfilled by our model. In simulation, one of the input variables, one or more of the input variables are uncertain. We do not have the exact value of those variables. Okay? So we try to replace or simulate that uncertain variable with probability distribution. For example, here we have x1 to xn. We want to find the optimal value for the output variable, but the problem is that one or more input variable, x1, for example, x1 and x2, are uncertain. We do not have the exact value of those variables. And we try to simulate these two variables with probability distribution. Probability distribution works like this. We have value and we have probability. Probability. For example, variable x1, its value may be 1 with probability 0.3. Its value may be 5 with 0.2, and etc. And all these probabilities must sum to 1. That's the definition of a probability distribution. We have value and the probability of this value to happen. So we try to simulate these uncertain variables with probability distribution. Instead of giving one value to these variables, we give it a set of input variables. For example, we have x1. It can take on 1 to 100 values. We feed these values to our model, and we get some output results for this variable. For example, 1, this is x1 to x100. We get these values, y1 to y100. These input values are called scenarios. We check different scenarios to get the best and optimal result for the output variable. So based on the result, we divide them into best case scenario, best and worst case scenarios. So scenario refers to the input variables, input values for each variable. For example, Walmart wants to sell something, but it doesn't know the demand for that product. It wants to put the new product into its shelf, but it has no idea about the demand of this product. They may have some estimation, prediction, but it's not exact. They try to simulate this variable with probability distribution and see what will be the kind of confidence interval for their profit. Okay? This is one of the uncertain variables. Demand is an uncertain kind of variable. Or in the opening case of this chapter, you see that in America West, which is an airline, they try to simulate behavior of the customers to lower the passenger waiting time or passenger boarding time. They try to simulate with a probability distribution. On Wednesday, I covered different type of probability distribution. We have uniform, which has two parameters, mean, max. We have normal distribution. These are the most widely used probability distribution. Uniform, normal, which has this shape. It is identified by two variables, mean or average and standard deviation. And we have triangular distribution, which has mean, three parameters, mean, max, and most likely. Mean, max, and most likely. And we have also binomial. This is a kind of discrete signal or binomial. So we try to simulate uncertainty with one of these models. For example, uniform is used when somebody asks you, how much is the price of this product? You may say, I don't know the exact number, but it may be something between $1,000 and $2,000. I have no idea, but it can vary between 1,000 and 2,000. This is uniform variable. Normal distribution can be used to simulate grades for an assignment. For example, the average grade of a class may be 95, but it has a standard deviation of 5. It may vary between 80 and 100. Minimum and maximum, it's exactly It's very similar to the uniform, but we know the most likely. For example, what is the uh, price of a product, or what's the cost of producing a kind of product? We know the minimum, maximum, and most likely. Suppose we see a luxury car in the street, and we have some estimation or prediction regarding its price. It may vary between $40,000 and $80,000, and it is most likely around $50,000. So we can model this kind of things with triangular distribution. So you will see different kind of examples for this probability distribution. We worked on this example. Please take a moment to read this example. This example is about a bookstore. Each calendar costs $7.5 and it sells $10, so its profit margin is $2.5. After January 1, all unsold calendars will be returned to the publisher for a refund of $2.5 per calendar. What's the objective here? And here we have another input. Walton believes that the number of calendar it can sell by January 1 follows some probability distribution with mean 200. So their expectation is to sell 200 calendars. Their objective is to find their profit margin. So we have some input variables like cost, price, and refund. They expect that their demand is something around 200. But that is their estimation. They do not have the exact number of demand because it is unpredictable. Their estimation is around 200. And they want to see what will be the profit margin for this model. We have two ways to deal with this kind of problem or exercise. One way is to use this exact number. But it is not always correct to use one single value to calculate the profit margin of a company. One way is to use the best case scenario. That's their guess that the demand is around 200. The other way is to use simulation. I will show you how these two models work. Best guess and simulation. For simulation, we can use probability distribution. Instead of giving one value, which is 200, we give it a set of input values and get the result. for all these input variables. And based on that, we can determine our profit margin. And the result will be more realistic. Here's the model. The name of the Excel file is Ordering Calendar Flow of Average. I want to show you the difference between a deterministic model, where we have one value, and its difference with simulation model, where we have a number of input values, to see which one is more realistic. In the deterministic model, we have these values. I'm going to define name for these values. We go to formula, define name for this value, unit price, unit refund, here in this model, in the simplest form, we have a value for this variable, demand. That's their guess. It may be correct or incorrect. Order quantity, and then they want to determine demand, revenue, cost, refund, to be able to determine their maximum profit. Okay. So now, revenue, it equals unit price times minimum of the demand and order quantity. Okay. Cost equals unit cost times order quantity. Refund equals unit refund times maximum of the difference between order quantity and demand and 0. Order quantity minus demand and 0. That's because we cannot return minus number of calendars. Whichever is bigger, order quantity minus demand or 0. And the profit is going to be revenue plus refund minus cost. C16 plus E16 minus cost. D16. So here is the result for this deterministic model. Our best guess for demand is 200, and based on this demand, that company or bookstore can obtain $500 profit. Is this always the case? What if the demand is lower or higher than 200? What's going to happen? Can we use this model, this deterministic model, to simulate a kind of realistic model? No, of course not. We have, in this model, we have one value. That's our best guess. It may be correct or it may be incorrect. So instead of using one value, we give it a number of input values and get some output results. And based on that results, we determine which one is the best case scenario and which one is the worst case scenario. So we use the same formula for the next model in simulation. Simulation model, demand equals B9 Okay. Revenue again equals unit price times minimum of the order quantity and demand. I have to define name for this one. Revenue equals unit price times minimum of the order quantity and demand average shown. Let's put B9. Order quantity. Cost equals unit cost multiplied by order quantity, and refund equals unit refund times maximum of the order quantity minus demand, B9. And for profit, it equals revenue, or C16, plus refund, E16, minus cost, D16. For the first part, we have this one. We have a deterministic value. For the second part, for the simulation model, instead of giving one value, we try to simulate this demand with a probability distribution. So we need to run risk. Risk is a package which is part of the decision tool suite. Do you guys have decision tool suite installed on your machines? Okay, so you should have risk on your machine. If you click on risk, you will get the risk tab here. Okay, so for the uncertain variables like demand, we need to go to distribution. In this example, we want to use normal distribution. So we click on distribution, define. So here's the normal distribution. And we have to set the parameters. We want to use, here we have normal with mean 200 and a standard deviation for t. So we need to set these values here. 200 and the standard deviation for t. Okay. These are the two values for this distribution, average and a standard deviation. Okay. Click OK. And we also need to set profit as our output variable. We select this one and we go to output menu, define it as our output variable. So profit is going to be the output variable. Do you guys have any questions? Is that clear? It's uncertain variable must be simulated with a probability distribution. So for this one, I used risk normal with 200 as average and 40 as standard deviation. We go to risk. And the profit must be defined as our output. Here's the output, and here's the input distribution. Mu or average is 200 and standard deviation is 40. Now, we want to run this model for 200 iterations, and we have one uncertain variable. So we need to set the simulation to 1. Now we can click on simulate to see what we get as the profit. You see the distribution of the output variable. The profit varies between minus 200 and 500. In the best case scenario, the profit is going to be 500, but it is 90% likely that the profit varies between 0 and this range. It is more likely to be less than 500, 450 and 0. In the best case scenario, our profit is going to be 500. So this is the more accurate model. We try to simulate it. We use 200 iteration. Iteration means we define 200 values as our input, whose average is here. Average is 200, but their standard deviation is 40. And the profit margin varies between 0 and 500. This way you can, for example, report to your manager that we cannot be optimistic about the profit. It varies between this range and that range, and that's up to you to choose whether to invest on this kind of product or not. That's how simulation works. So first we have to define a probability distribution as for the uncertain variable, and then we have to define our output variables. Does that make sense? Yeah. Okay. We worked on this example on Wednesday, but it didn't create the correct results. So I wanted to repeat that and also emphasize the different part of a simulation model, because we will be working with different kind of examples in chapter 16. And it is very important. And we can print graph. We can define it as a new chart. And these are the associated values for these variables, x1 and y1, and etc. Here is the result. All right. Is there any questions? Was that clear? Okay. If something is not clear, please let me know. I can go through another example. Yeah. Yeah. Yeah, I like this textbook too. I think its authors are from IU Bloomington. And yeah, they did a great job, and I like this book. I use it not only for this course, but for my other data analytic courses. I covered the first chapters, and they provide a lot of information with great examples. Yeah, yeah, that's all for today. I just wanted to repeat my example that I covered on Wednesday because this model, we didn't get the correct result on Wednesday. So hopefully in the next week, we will go through some other example. We will work with some other probability distribution and different kind of examples. Thank you very much.